Assalamualaikum and hello everyone. My name is Muhammad Fawwaz Redha bin Muhammad Fazli, and today I will be presenting my analysis of research article titled Machine Learning Based Biomarker Discovery for Chronic Kidney Disease Mineral Bone Disorder. This article is authored by Yu Ting Li, Yu Kolo, and the other team member, and it was published in BMC Medical Informatics and Decision Making, also Springer, and also Biomed Central, and was published in 2024. For the training dataset, there are 116 patients, 70 male and 46 female, and for average of age is 60.9 plus minus 12.9 years, and there are 86 blood biochemical features are collected, features with 20% missing values removed, and finally we have 160 patients and 65 features. For validation datasets, we have 114 patients from separate cohort, same pre-processing pipeline applied, used for testing model generalizability, and also blind test and not used during training. For CKD-MBD classification subtypes, there are CKD-MBD calcium, CKD-MBD phosphorus abnormality, and CKD-MBD PTH, which is parathyroid hormone abnormality, and CKD-MBD NE. This is the general case from the other three subtypes. For the process and methodology, data collection and pre-processing, we're cleaning the 160 patient datasets down to 65 usable features. And for the correlation analysis using Pearson SPM coefficients, the results showed most features are only weakly correlated with the CKD-MBD labels only, and which makes the feature selection step both necessary and also challenging. For the third one is F-test ranking. All 65 features were ranked by how well they separate CKD-MBD patients from healthy controls. And the fourth one is question forward feature selection. Starting from the top ranked feature, each additional feature is only kept if improves the AUC score and they leave one out cross validation. And the six machine learning classify use KNN, EK equal to 1, SVR which with polynomial kernel, linear regression, 13 features selected. They use 5 hidden layers, and logistic regression, binomial or logic, and random forest, they use 100 trees. For output of the result, CKD MBD any subtype, linear regression is achieved the best training AUC, area under the curve of 0.95, selecting 3 features. The consensus biomarkers identified across all the 6 classifiers for the subtypes were pre-hemocreatinine, mean hemoglobin, and LDL. For the other subtypes, KTV and GH were flagged for calcium abnormality, eosinophil count for phosphorus and phosphemocreatinine, alkaline phosphates, and globulin for PTH abnormality. When tested the unseen validation set, the AUC drops. The best was 0.74 for CKD-MBD NE, which is the general one, while CKD-MBD PTH dropped to only 0.58, which is barely than random guessing. For limitations, there are several limitations identified in this study. First, the sample of size only is 116 training patients. It's very small for clinical ML model and increasing the risk of overfitting. And the second one, all data came from single hospital in China, which limits generalizability to other populations. And the third one, the significant drop in validation AUC. And also the fourth, the study only use tabular blood test data and does not incorporate genomic, proteomic, or imaging data, which are commonly used in similar modern biomarker studies. And important clinical context such as CKD, stage, and medication history are missing. And the last one is no explainable AI analysis, particularly for the DNN model, which limits the clinical trust. And for proposed improvement, we have 4, which is expand dataset via federated learning to aggregate multi-center data without sharing raw patients record using federated learning. And also we can integrate multi-omics data to incorporate genomic, proteomic, and metabolomic data alongside biochemical features to enrich the input feature space. And also add explainable AI such as Sharp or Lime to provide feature importance explanation for each patient's prediction from DNF and DNN and random forest models. And also the last one is deep learning for time series CKD progression. We use LSTM or transformer-based models to longitudinal patient records to predict CKD MBD onset over time rather than a single static snapshot. For the summary, this is first ML study applying machine learning to identify alternative biomarkers for CKD-MBD using 65 blood biochemical features. There are 6 classifiers plus sequential forward feature selection under LOOCV identified, concise biomarkers panels for 4 CKD-MBD subtypes, and the best training AUC is 0.9 using linear regression on CKD-MBD NE, which is the general one, and validation AUC is dropped to 0.74, show promise, but generalizability is limited. So that's all from me. I hope you guys enjoyed. Thank you.